Okay, section 9.6 is dilations. Now this is the first of our transformations that is a non-rigid transformation. In other words, as the title indicates, it's going to change the size. All right, so a dilation, dilation with a center of dilation C and a scale factor n greater than 0 can be written as d of n comma c. In other words, n is going to tell us how much bigger we are multiplying something by to make it bigger or smaller. C is where that center of dilation is, and of course the d stands for dilation. So a dilation is a transformation with the following properties. The image of C is itself. So anything right at the center of dilation is going to stay exactly the same. So C prime equals C. For any other point R prime is on the line CR, the line starting at the center of dilation and passing through the original point. And CR prime is n times bigger than CR. It should be a prime up there. Or in other words, C prime divided by CR, the dilation divided by the original, gives you the n, or the dilation factor. So we're taking something and we're multiplying it twice as big or 3 times as big, or even in some cases smaller, half as big. Dilations preserve angle measure. They do not preserve size. Okay, a few other things about dilations. The scale factor n of a dilation is the ratio of a length of the image to the corresponding length of the pre-image, with the image length always in the numerator. That's what we showed on the last screen. The image divided by the pre-image. So if the image is larger, the dilation factor will be greater than 1. If the image is smaller than the original pre-image, the dilation factor will be less than 1. And that's what this says. A dilation is an enlargement if the scale factor n is greater than 1, and a dilation is a reduction if the scale factor n is between 0 and 1. You notice that the n factor is never considered negative. Okay, so let's look at a picture. Here's a pre-image, or pre-image, ABC, and an image of dilation, because it's bigger, A prime, B prime, C prime. And our center of dilation here is at 0, 0, or at the origin. So let's see if we can find out what is the dilation factor. So if I know that everything is going from the origin, and if I have OA, and then I have OA prime, you notice they're on the same line. If you take the distance from the origin to A, and then the distance from the origin to A prime, hopefully you can see that it is twice as long. Same thing happens if I go from O to B, and then O to B prime. You can see that we are doubling our length here. And the same thing from O to C and O to C prime. Another way to look at this is that the point for A is 2, 3, while A prime is 4, 6. From the origin, I have doubled my x and y distances. B was 2, -2, whereas B prime is 4, -4. Everything has been doubled. And C is at -1, -4, whereas C prime is -2, -6. So my factor here, my dilation factor is 2. The center of dilation is the origin, and I can easily find from my pre-image, I can calculate my image. We'll do another one of these in class together, but that's enough